Let's go to persistence. Persistence. RDD can be persisted in memory or hard disk. RDD can be persisted in RDD can be persisted in memory or hard disk. RDD can be persisted in memory and hard disk. What is the advantage of persisting RDD? What is the advantage of persisting RDD? Let's take one scenario. I will show one scenario. First we loaded file. So file is loaded into RDD 1. From RDD we applied some transformation dot T1 or T1, we got RDD 2. On this RDD we executed T2, we got RDD 3. From RDD again there are some other operations. So we applied RDD on RDD, we applied transformation 3, we got RDD 4. On this RDD, same RDD, we executed transformation 4. We got RDD 5. So in this RDD we applied transformation 5, we got RDD 6. In this RDD we applied transformation 6. Then we got RDD 7. Then in this one I applied action 1. In this RDD 7 I applied action 2. So when we execute action 1 and action 2, if you execute action 1, file is loaded into RDD 1, RDD 2 is created, RDD 3 is created, RDD 4 is created, RDD 6 is created, then action is performed, right? Then if you apply action 7, action 2, file is loaded into RDD 2, RDD 2 to RDD 1, RDD 1 to RDD 2, RDD 2 to RDD 3, then RDD 3 to RDD 5, RDD 5 to RDD 7. Finally action is executed, right? Once action is completed, it removes this memory from memory. It removes complete memory from complete RDD's memory from memory, right? Yes or no? So in this flow, which is mostly used RDD? Viren, which is mostly used RDD? Ravi, which is mostly used RDD? RDD 3, right? Yes or no? RDD 3 is mostly used RDD. So if you apply action 1 or action 2, it is executing this entire flow, right? So if you persist this RDD, what will happen? Observe. If you persist this RDD, what will happen? Whenever action 1 is executed, it require RDD 6. RDD 6 required RDD 4. RDD 4 required RDD 3. RDD 3 is already available in memory. So it won't execute this entire flow. It directly return from this RDD to RDD 4, RDD 4 to RDD 6, and action is executed. If you apply action 2, already RDD 3 is persisted. So flow is communicated from in this location to this flow. It reduces complete flow, right? this flow. Yes or no? Because of this, we are improving performance of our Spark application. If any RDD is mostly using, we persist that RDD so that we improve application flow. Yep. So file loading and RDD1, RDD2 and RDD3 is only one time. But next time if you perform any action in this flow, it comes from here only. First action, it will go from file loading to RDD1, RDD1 to RDD3. Once this RDD3 is persisted, you can apply any actions. Flow is coming from RDD3 only. Okay. Yep. See, we will see whether RDD is persisted or not in Spark Web UI. I will show you Spark Web UI. There is one class called storage level. There is one class called storage level. This storage level class has different persistent methods, persistent constants. We use that persistent constants to persist our RDDs. So this storage class has different persistent levels. We use that persistent constant to save our RDD. So this storage class is available in org.apache.spark.storage. So this is storage package. So we have to import this package. Okay. This package contains storage level class. So without importing this package, we cannot see storage level classes. Storage level class. Okay. So what I'm doing in our desktop, we have our Spark workspace, right? Spark and Scala. In Spark and Scala, what I'm doing, we have batch 3. Under batch 3, we have workspace. Under this, we have Spark core, right? Here, what I'm doing, I'm writing one import file. So what I'm doing, I'm writing one import org.apache.spark dot underscore. This is one package. And next one, spark dot storage dot underscore is another package. And next what I'm doing, uh, I'm writing val uh, conf equal to new spark conf next one I'm setting master name conf dot set spark dot master master I'm setting local and I'm assigning all cores to my application. Next one conf dot set, I'm setting application name spark dot app dot name. So name is Spark application, Spark app. Next one I'm writing val sc equal to new Spark context, and I'm passing configuration object. Okay. So up to this part I'm setting, and next sc dot set log level, and I'm setting warning. Okay. Set log level equal to warning. So that's it. I'm saving this one into just my file name I'm saving imports. What I'm saying, imports. Instead of every time writing this one, what I do in my SBT cell, once SBT is started, just I load that file so that my complete imports and Spark context is created. In next class also, instead of writing all the statement, I can use this imports file. Let's type console. Okay, let's colon load imports, colon load imports dot txt. It will load that file. So loading, importing packages as well as creating Spark context. Next, it is creating Spark context. Configuration is created, context is created. Okay, just to type SC, press enter, uh, type SC and press enter. You will see a reference of that Spark context. Okay, Spark context is object is created. Now, what I am showing, I am showing. Let me open that URL, localhost colon 4040. So here you will see storage, right? In this storage, we will see if you persist any RDD, we will see here. We will see that persisted RDD information here. Okay. So we have persistent level is called memory underscore only. We have persistent level called memory underscore only. What is this memory underscore only means? It will persist RDD in memory. Memory means RAM memory in deserialized, without replication. Without replication. So RDD has multiple partitions, are right? So partitions, when you save this memory, when you save RDD in a memory, it will not create any replication factor by default. By default, it will not create any replication factor. What is deserialized mode? We will see in next. We will see in next example. First, understand, whenever you use memory underscore only, it will save RDD in memory in deserialized format without a replication. If you want a replication, we will specify how many replications we want. Okay, so let's go and connect. This is our application. Here in workspace we have data. So this is my call log data. What I'm going to do, so if you place this call log data in application location, in this location, if you save this one call log data in this location, you can directly use import, connect to that one. So next, what I'm doing, I'm creating RDD. So val RD1, I'm creating val RD1 by loading file equal to sc dot text file. What is our text file name? Call log data. Call log data. sc dot text file. Call log data. So what I'm doing, R1 dot get num partitions. Get num partitions. So we assigned in my system. I said how many cores presented? Core. 4 cores, right? In that 2 cores are allocated for Windows. So remaining 2 cores are allocated for my Spark application, because local of star. How many free cores are available assign that number of cores to our application, right? Yes or no? So when I say R1 dot get num partitions, I will see number of partitions are 3. Get num partitions are 3. So it is created 3 partitions. Maybe I have more cores. That's why it is created 3 partitions. If I change this one, instead of a star, if I assign number of partitions are 2, sorry, number of cores are 2, it will assign, it will create 2 partitions, right? Yes or no? Team? Okay. So based on here parameter, it will create those many partitions default. Can we change number of partitions for RDD? Can we change partitions? Can we increase in application? Can we increase number of partitions? Can anyone tell me, can we increase number of partitions or not? No one is responding. I think no one is here. One class, in one class I explained repartition. Repartition. No, no, Hemant, you are wrong. Did you attend repartition concept? Repartition. By using repartition, we can increase, right? I said repartition. By using repartition, we can increase number of partitions. Okay. Initially, we are setting partitions. We are setting. We are not setting partitions. We are assigning number of cores. Based on this number of cores, it is allocated 2 partitions for our RDD. If you want increase number of partitions, then we go for repartition concept. You can increase any number of partitions. What is the advantage of increasing partitions? Can anyone tell me what is the advantage of increasing partitions? If number of partitions are there, then number of executors execute partitions, right? So parallel processing, we can improve parallel processing. If you increase parallel processing, what will happen? Speed. Yes, you are correct. So it improves automatically performance. So we increase number of partitions so that it will improve performance. One important point, we can achieve parallelism, we can achieve speed. Okay. So next what I'm doing, I'm persisting storage level. I'm persisting RDD. Let's apply persist. So I'm persisting RDD1, persisting RDD1, where I'm persisting, what is the storage level I'm using? Memory underscore only. What is memory underscore only? It will persist R1 RDD in memory in deserialized mode without replication. Without replication means only one copy. Let's go browser and verify storage level. Still there is no RDD persisted. Why? Can anyone guess why RDD is not persisted? Can anyone tell me why RDD is not persisted? When memory is allocated for RDD, can anyone tell me when memory is allocated for RDD? Action is executed. Super Ravi. Only Ravi is inactive. Whenever we execute action, memory is allocated for RDD, right? Till now, we execute any action? We just created RDD. We just saved RDD, but we did not execute any action, right? So if you not execute any action, then we cannot say memory is allocated, right? We can say, when we can say memory is allocated, when action is executed. When action is executed, it will load memory, it will create memory, then it will persist that RDD. Let's execute r1 dot count, r1 dot count action. Okay, so this is these many records, right? Let's go browser, refresh, see storage, call log data, and memory serialized. One replication factor is 1, means there is no replicated. RDD is not replicated. Cached partitions are 3. Cached partitions are 3. What is the memory of this RDD? 197 MB. Let's save these details. Let's save these details. So memory underscore only, right? Memory underscore only. So this is memory deserialized. One replication equal to 1, replicated equal to 1, right? Next, let's see memory underscore only, but serialized. Memory underscore only with serialized. So without serialized, see the size is 197 MB, right? So what I'm going to do, I want to create R1, I want to save R1 in serialized mode. So for that one, I'm using R1 dot persist storage level memory underscore only underscore ser, means it serialized, it applies serialized. Let's execute this one. See, observe what will happen. Here we get one error. What is the error? Observe. It giving error saying unsupported operation exception. Cannot change storage level of an RDD after it was already assigned a level. What is the meaning of this statement, friends? If any RDD persisted, we cannot change RDD persistent level. We cannot change RDD persistence level. I want to new persistent level. Then we have an option called R1 dot unpersist. Unpersist. We have to call unpersist method to remove previous storage level state. Then execute R1 dot persist storage level dot memory underscore only serialized. So this time we are applying memory underscore ser. Memory underscore ser. We will see this difference. Memory underscore serialized. So this is serialized. Replicated is 1. Then what is the features of this one? Observe. Let's go to browser. Let's refresh. There is no RDD. Why? We persisted RDD, but we did not execute any. After persisting, we did not execute any action, right? Let's execute action. R1 dot count. R1 dot count. Or let's take R1 dot take of 2. Anything. Dot for each of println. So I executed take action. Okay, let's go browser. Let's refresh. We will see RDD, right? Let's copy this one, copy this statement, copy this data, and go to notepad and paste this one. Some things are not copied. Observe call log data. This is memory, but above one is deserialized. This is serialized. Replication is one. Replication is one. Okay. So without serialization, what is the size of call log file? 197 MB. After serialization, what is the call log file size? 32 MB. So it is compressed and saved in memory, right? RDD is compressed and saved in memory, right? So if you apply memory underscore only underscore serialize, what will happen? It will compress and saves in memory. What is the advantage of memory underscore only underscore serialization, friends? What is the advantage of second storage level than first storage level? Friends, what is the advantage of second approach? Are you there? So yes, Ravi. Yes, less memory. You are correct, Hemant. Correct, Ravi. It it will occupy less space in memory, right? So what is the what is 197 MB? What is 32 MB? So almost 70 or 80% memory is reduced, right? Yes or no? It is compressed, compressed format. See, what is 100%? What is 33%? Around 67% is compressed, right? And what is the advantage of memory underscore only than memory underscore only underscore serializable? What is the advantage of first approach than second approach? We know advantage of second approach. Second approach occupies less memory. What about the first one? What is the advantage of first one than second one? Can anyone tell me what is the advantage of first one compared to second one? One question. Viren asked, how does Spark reduces the data to such level? So this is internally Spark uses compression techniques, wherein we are not doing anything. We are just using the storage level. That's it. Internally Spark will taken care. They written multiple application to compress the data, not block. Internally how they are compressing, we don't know. That is taken care by Spark engine. Okay. My question is, what is the advantage compared to second one with first one? What is the advantage? That's what I am asking. It will what is the, so if you understand advantage of first one compared to second one, then you will come to know Viren. Can anyone tell me what is the advantage of first one compared to second one? Whenever you are displaying or whenever you are applying any display or calculation or any other application apply, if you apply anything, this is direct to data, right? Deserialized data. So performance is very faster compared to here. If you apply any action, this is serialized data converted into deserialized, then execute operation, right? So serialized converted to deserialized, then action is executed. So conversion will take time, right? So performance wise, this one is faster than this one. That performance also taken care by Spark engine, little, not high performance, little difference, because Spark engine uh, performs serialization to deserialization very faster, because Spark only has that technique, right? Conversion technique. That serialized data format is converted by Spark engine, right? So deserialization also conversion taken care by Spark engine. So Spark cannot take much time to convert a serialized object into deserialized object. It will take less time, but that less time is impacts on huge volumes of data, right? Yes or no? But little different, not a high, little performance wise, little faster. First one, okay. Most of the time, most of the time we go for second one. Why we are going second one? We are persisting RDD in where RAM. RAM is very less memory. Yes or no, Viren? So here memory is very less. That's why we perform serialized, because we get less memory sizes. So if you store huge volumes of data in memory, it occupies entire memory. That's why what we do is we will apply serialization technique. We are not doing any serialization. We use one, this is called constant. We apply this constant. It will taken care internally. Spark engine taken care to perform serialization. 1 minute. Viren asked one question. Serialization is for saving the state of the object, right? Yes. Not object, saving the state of RDD. This memory techniques have serialization and deserialization. Okay, saving RDDs.